Well, here we go again. You probably remember that in our last lesson we did multiplying integers, and in that lesson we wound up with discussing that a positive number times a positive number equals a positive number. A negative number times a negative number also equals a positive number. And then if you mix the two, you take a positive times a negative or a negative times a positive, what you end up with is a negative number. Today we're going to proceed with talking about something called a multiplicative inverse. And with a multiplicative inverse, this is any two numbers that you multiply whose product is 1. And that's the important thing to remember, that after your multiplication is done, your answer is equal to 1. And when that happens, you have two numbers that are multiplicative inverses. So if I put the number 4 on my screen here and asked you what the multiplicative inverse of 4 was, remember your answer is going to equal 1. And what we would multiply is 1/4. So 1/4 times 4 equals 1. Some of you might look at a fraction. If you had 1/12, the multiplicative inverse of 1/12 would be just to multiply it by 12, and that would equal 1. So multiplicative inverse is very simple. That is what you do. Continuing right along then, division is just like multiplication. If you take a positive number and divide it by another positive number, your answer will be positive. If you mix the two, a positive divided by a negative or a negative divided by a positive, your answer will be negative. And then the final one, if you're taking two negative numbers and you're dividing them, your answer is going to be positive. So the rules are they're the same as with multiplication. Your answers turn out the same. Rules for adding integers then, if you have the same sign. So you're taking a positive number plus a positive number, your answer is going to turn out positive. A negative number plus a negative number, your answer will turn out negative. Just to illustrate this point that I'm talking about, I have taken a negative 3 and there's my plus sign, so I'm adding integers, and I'm adding a negative 7 to negative 3. My signs are both the same, so I will add them together to get 10. And then remember to bring your sign over. This is where kids usually make their mistake, not bringing that sign over. It stays a negative 10. I have the same thing going on in this next example. I have a negative 7 plus a negative 13. My math operation is addition, so I'm adding two integers. The signs on my integers are the same. I have a negative and a negative, so negative 7 plus negative 13 is negative 20. And again, remember to bring your sign over. That's really probably the most common mistake kids will make, is to lose that sign. I do that myself from time to time, so just be real careful with your negative signs when doing integers. Just to review then, for adding integers, if your signs are the same, you add and keep the sign. If the signs are different, that means you subtract and keep the sign of the larger. I want you to try to think of an equation where the signs are different, and I'll give you a second or two to think about that. Here is my example of when we have different signs. We're still doing the addition, so we're adding integers, but note I have a negative 4 plus a positive 9. So the first thing it does is it tells me to subtract and keep the sign of the larger. Well, 9 has a bigger absolute value than negative 4, so after I do my subtraction here, my answer is going to be positive. So 9 minus 4, should remember that from elementary school, is simply 5. We write 5. We do not put the negative sign there because 9 had the larger absolute value than negative 4. It's further from 0 than negative 4 is. And that's all you have to do when you have different signs. Subtract and keep the sign of the larger. So just thinking that through, if we are going to add numbers and we have one that's a positive and one that's a negative, just like in my last example with negative 4 plus 9, I have to decide which one has the bigger absolute value. So what number is further from 0? You know, if I had negative 32 plus 7, negative 32 has a larger absolute value. So my sign on a problem like that would be, and let me just show you what I'm talking about. So I'm writing negative 32, and I said I was going to add 7 to that. So there's my adding integers, my plus sign there, and then I draw my 7. And then I have to ask myself which has the bigger absolute value, which is farther from 0, and it's negative 32. So you can do this. In fact, before I do any math at all, I know my answer is going to be negative. All right, if I take 7 from 32, I go down 2, I'm at 30, and then I go down 5 more, and I'm at 25. Negative 25 is my answer. Okay. Additive inverses then. Additive inverses is extremely simple. When we're done with a problem where we're defining the additive inverse, we just have to remember that our answer needs to be 0. The sum is going to be 0. So I have an illustration there of an additive inverse. 5 plus a negative 5 equals 0. If I had 100 plus some number and it equals 0, the answer to that would be negative 100. If I have negative 1000 plus some number and I want it to equal 0, the additive inverse would be a positive 1000, because a negative 1000 plus a positive 1000 does equal 0. Additive inverses, very simple. You want your answer to be 0. With our rules for subtracting integers, a lot of the times best practice is to turn that into an addition problem. But if we have a negative number minus a positive number, a good rule of thumb is to remember is that your answer is going to be negative. What I have illustrated here is exactly that situation. We have a negative 4 minus a 3. And that, because my signs are the same, I have a negative in front of a 4 and a negative in front of my 3. My answer is going to be negative 7. If I change that into an addition problem, as I have at the bottom, my negative 4 stays the same. My subtraction sign, that minus sign, becomes a plus sign. And then you have to change the sign of the number that follows the subtraction symbol. So my 3 turns into a negative 3. Thus, negative 4 plus negative 3 equals negative 7. This is the same equation as minus 4 minus 3. So our rules for subtracting integers, they tell you to change the subtraction sign to addition, and then change the sign of the second number, and then perform the computation. I have a practice problem written here now. It says 4 minus 8. If I turn that to addition, I change my subtraction sign to addition. The 4 I leave alone. The sign on this 8 I need to change, so that is going to become a negative 8. Now, what has the larger absolute value? Which one is further from 0, 4 or 8? Well, the answer to that is 8. So my answer here is going to be negative, because the negative 8 is further from 0. 8 minus 4 is 4. So my answer, negative 4. So there I perform the computation, and just reviewing again with changing the subtraction sign to addition. That's what I did right here. I left the first number alone. I had to take this 8 and change the sign of that 8 to a negative 8. Okay, this negative sign turned into the positive sign. So then I performed my computation and I got negative 4 as my answer. Remember, if you're confused by this, you can stop the video, you can pause it at any time, and then you can rewind and you can watch it again and again until it starts to sink in. Best practice with integers is just to go really slow and be careful with your negative signs. Just to review that one more time, in the rules for subtracting integers, if we took a positive number minus a negative number, our answer would be positive. Okay, and I've illustrated that below in this problem. Positive 8 minus a negative 3 equals 11. Okay, and I can sort of illustrate that in two ways. You have negative, negative. Well, what is negative times negative? It's positive. So that's where my 8 plus 3 comes from. When I add 8 plus 3 together, I get my answer as 11. So one final time in looking at your rules for subtracting integers, I have 8 minus a negative 3. That's like a double negative, so we change that to a positive. That becomes 8 plus 3. Below I have 10 minus a negative 8. Negative negative becomes positive, so I have 10 plus 8. The answer to 10 plus 8 would be 18. And my piece of advice for you is that until you get these rules memorized, feel free to watch this video as many times as it takes to commit those rules to memory.